Dear students, now we are going to solve one important problem in the characteristics of TE waves and TEM waves between parallel planes. So before going to solve the problem, let's discuss the important formulas used in parallel plane. The first one is propagation constant, that is represented as gamma is equal to square root of m by a the whole squared minus omega squared mu epsilon. Here a is the separation between the parallel planes. Okay. So next m is the mode of the waves. For example, TM10. So in this one represents m value. Okay. At frequency less than the cutoff frequency, the attenuation constant alpha is equal to square root of m by a the whole square minus omega squared mu epsilon. There is no wave propagation. So if there is a wave propagation, then the phase shift constant beta is equal to omega squared mu epsilon minus m by a the whole square. Okay. So here we can consider the operating frequency is greater than the cutoff frequency, then alpha is equal to 0, beta is equal to omega into square root of mu epsilon. Okay. So the next one is cutoff frequency. The formula is Fc is equal to m by 2a square root of mu epsilon. Here 1 by square root of mu epsilon is nothing but the velocity of propagation. So we can write the cutoff frequency as mv by 2a in terms of hertz. Okay. For air medium, this velocity of propagation value is equal to the velocity of light 3 into 10 to the power 8 meter per second. Okay. So the same equation can be represented as m into c by 2a. Okay. So the next one is cutoff wavelength. So here the formula is lambda c is equal to 2a by m. So in terms of meters. So guided wavelength lambda g is equal to lambda by square root of 1 minus lambda by lambda c, where this lambda is nothing but the free space wavelength. It can be obtained using the formula c by f. C is the velocity of light. Okay. The next parameter, phase velocity. So here the phase velocity is equal to omega by beta, that is equal to v by square root of 1 minus fc by f the whole squared. Unit is meter per second. For group velocity, the formula is v into square root of 1 minus fc by f the whole square. The relation between the phase velocity and group velocity is given as v squared is equal to the phase velocity multiplied with the group velocity. Okay. So next, characteristics impedance eta is equal to square root of mu by epsilon. For air medium, the characteristics impedance value is 120 pi or 377 ohm, because mu naught value is equal to 4 pi into 10 to the power minus 7 Henry per meter. Epsilon naught value is 8.854 into 10 to the power minus 12 farad per meter. So we can substitute this value in this formula to get the value as 120 pi or 377 ohm. So the last one is wave impedance. For TEM waves, its formula is eta into square root of 1 minus fc by f the whole square. For TE waves, its formula is eta by square root of 1 minus fc by f the whole square. So then the relation between these two wave impedance is given as eta squared is equal to ZTE into ZTM. Okay. Now we are going to solve one important problem in parallel planes. A pair of perfectly conducting planes are separated 8 cm in air for frequency of 5000 MHz with TM10 mode excited. Find the cutoff frequency, characteristics impedance, attenuation for f is equal to 0.95 fc, the phase shift constant, velocity and wavelength. Okay. So in this problem, the separation between the parallel planes is given as 8 cm. The mode is TM10 mode. we are going to find out the characteristics for the given mode TM10. So in the solution part, first we are going to write the given data. So here the separation between the parallel planes is 8 centimeter. So we have to convert the centimeter into meter as 0.08 meter. The mode is TM10 mode. From this we can get small m value is 1. Okay, the operating frequency is 5000 megahertz. So it can be converted into 5 into 10 to the power 9 hertz. Okay, so here the medium is air, hence the mu r and epsilon r values are equal to 1. So now we are going to find out the cutoff frequency using the formula m by 2a square root of mu naught epsilon naught. Correct? Actually the formula is m by 2a square root of mu epsilon. Here this mu epsilon is nothing but mu naught mu r epsilon naught epsilon r. So mu r and epsilon r values are equal to 1. So we can write 1 by square root of mu naught epsilon naught. Then that value is nothing but the velocity of propagation. So the same formula can be written as m into c by 2a. So here we can substitute the values of the velocity of light m and a. We can get 1 into 3 into 10 to the power 8 by 2 into 0.08. We can get the cutoff frequency as 18.75 into 10 to the power 8 hertz. So it can be written as 1.875 in 10 to the power 9. 10 to the power 9 is nothing but giga. Do you all understand this one? So next we are going to find out the characteristics impedance. So characteristics impedance is nothing but square root of mu by epsilon. Here it can be represented as square root of mu naught by epsilon naught. We can simply substitute mu naught value as 4 pi in 10 to the power minus 7. Epsilon naught value as 8.854 into 10 to the power minus 12. Then the answer is 120 pi or 377 ohm. Okay. Next we are going to find out the attenuation for f is equal to 0.95 fc. So here the operating frequency is less than the cutoff frequency. Hence we can use the formula alpha is equal to square root of m by a the whole square minus omega square mu epsilon. So here this omega can be written as 2 pi f. So 2 pi f the whole square means 4 pi squared f squared. Here pi squared is common. We can take it outside from the square root as pi. So here pi into square root of m value is 1, a value is 0.08 the whole square minus 4 into then f value is what? 0.95 fc. Correct. This f value is what? 0.95 into fc. We have already calculated this value fc, right? So we have to substitute this value here. So 0.95 into 1.785 into 10 to the power 9. The whole square multiplied with mu naught value as 4 pi in 10 to the power minus 7 and epsilon naught value is 8.854 in 10 to the power minus 12. Then we can simplify all the terms and finally we can get the answer as attenuation constant alpha is equal to 12.3 Neper per meter. Do you all understand this one? So whenever the operating frequency is less than the cutoff frequency, the alpha value is not equal to 0. If the operating frequency is greater than the cutoff frequency, then alpha value is equal to 0. Do you all understand this concept? So next we are going to find out the phase shift constant. So we actually in this problem they have given the operating frequency f value as 0.95 fc only for finding out the attenuation. But for this phase shift constant we can consider the frequency as 5 into 10 to the power 9 hertz. That means 5 gigahertz. Okay, so this value is far greater than the cutoff frequency. What is the cutoff frequency here? 1.875. Okay, so that is the value here. Then we can use the formula beta is equal to square root of omega square mu epsilon minus m by a the whole square. Then we can substitute all the values in this formula to get the beta value. So what is the beta value? This value is 97.07. Next, we are going to find out the phase velocity. Vp is equal to omega by beta. So this omega can be written as 2 pi f. Then we can substitute the values of f and beta here. So Vp is equal to 2 into pi into f value is what? 5 into 10 to the power 9 divided by beta value is 97.07. Then we can get the phase velocity value as 323.6 into 10 to the power 6 meter per second. So next, group velocity. So for this we can take the relation between the phase velocity and group velocity. So here the velocity of propagation is equal to square root of Vp into Vg. We can get the value of this Vg from this formula. So here the group velocity is equal to V squared by Vp. So what is V squared? For air medium, V is nothing but the velocity of light. So we can get the group velocity is equal to 3 into 10 to the power 8 the whole squared by the phase velocity is 323.6 in 10 to the power 6. The answer is 278.1 into 10 to the power 6 meter per second. Okay, and the last one is wavelength along the guiding structure. Wavelength along the guiding structure means guided wavelength. So here the formula is guided wavelength is equal to lambda by square root of 1 minus lambda by lambda c the whole square. Here this lambda is nothing but the wavelength in free space condition. So here we can get lambda is equal to c by f. Lambda c is the cutoff wavelength. The formula is 2a by m. So we can find out the values of lambda c and lambda by using this formula. So lambda c is equal to 2a by m. 2 into a value is 0.08 by m value is 1. We can get 0.16 meter and lambda is equal to c by f, that is 3 into 10 to the power 8 by 5 into 10 to the power 9. The answer is 0.06 meter. Then we can substitute these values in this formula to get the guided wavelength. Then we can get the answer as 0.0647 meter. Do you understand this one?